Okay, so moving right along to chapter 6. This chapter is entitled Rules of Thumb. There's a whole bunch of controversy about that term and about which thumb to show. So here's my actual thumb. Hopefully that doesn't cause any consternation. So as always, Munzner starts out with the big picture, except this one isn't a picture, it's a list, and these are the rules. So the first one is no unjustified 3D, and we'll talk about each one of these in turn. Second is no unjustified 2D. You know, if you can get away with representing in one dimension or with a list, then there's not a need for a two-dimensional graphic. Eyes beat memory, resolution over immersion, overview first, zoom and filter, and then detail on demand. That's a mantra from the graphical user interface design class. Responsiveness is required. Get it right in black and white. Function first, form next. So let's take a look at each one of these, and we'll start out with the no unjustified 3D. And 3D is awesome, and it's the best solution for understanding shape and three-dimensional structures. However, in most cases, it's just not justified, and it presents a large number of problems. One thing is with humans, we actually have trouble perceiving depth. And even when we're looking in 3D, we tend to focus on a plane. So we don't see everything in depth perception. We tend to focus on just a plane. For example, right now I'm focusing on the screen of my computer as I'm giving this little talk. I'm not focusing on everything in the background. Even though I'm seeing in 3D, a lot of researchers are fond of saying we see in 2.05D. So we see 2D plus a little bit more that appears in the background. Another problem with 3D is occlusion, and that means that some objects cannot always be seen. This isn't necessarily a bad thing since it acts as a cue for depth. It also changes as we move. So things that are closer to us tend to move by faster than things that are further away from us. That's a concept known as parallax. And some important information can be hidden with occlusion, and it imposes a cognitive load on the user in order to understand the scene. Another problem with 3D is distance, perspective distortion, and depth cues are thrown off. Distant objects appear smaller, and then our perspective is generally thought of as a good thing. The whole idea behind the Renaissance was bringing in that power of depth. However, in visualization, you lose the power of the plane, and it's really, really difficult to judge 3D bar graphs, as some of your bad visualization presentations pointed out. Depth cues are based on the size of familiar objects. So how big are these that you're seeing here? Well, there's no familiar object on which we can base this. What is the unit on which we're basing our visualization here? And it's also good to have shadows and surface shading. And again, you don't really see shadows or shading here to give you that idea of depth. That being said, 3D can be good, and it's often good when you require an understanding of structure of the scenes or the geometry of the three-dimensional space. For example, blueprints, coral reef visualizations that John Burns does, fluid dynamic flows, those are all great uses of 3D. But again, going back to no unjustified 3D, you should have good justification for it. Now, both these visualizations in this picture show the same information. That's energy consumption in an office. And here, the two-dimensional model makes it easier for you to understand what the actual patterns are. And the only thing to note is that these are Dutch calendars, and the weeks go down by column and then go over to the next column, over to next column, over to next column, versus our calendars that generally go by rows for the weeks. But here you can see different patterns. Like you can see that there's a large amount of energy consumption that takes place in June, July, and August, and that's probably because the air conditioning's on. You can see that the weekends, Saturday and Sunday, are blue and don't require very much energy. It's harder to see that in the three-dimensional figure there. even 2D. If you can get away with a one-dimensional structure, such as a list, then go ahead and do that. Basically, you're showing the maximum amount of information, taking up the minimum amount of space. It's great for lookups and searching through it. And there are some tasks that are handled very well by lists. Pictured is a book called Flatland, which deals with dimensions that we can't see, and it basically takes place in a plane, but there is actually a third dimension, and it throws the whole Flatland into a tizzy when they actually find out there's a third dimension. So it's a really good book. I think it was Edward Abbott who wrote that one, but don't quote me on that. ISB memory. Visualization has a lower cognitive mode than consulting our memory. In fact, working short-term memory is a pretty limited resource, as depicted by Cheech Marin here in the photo. We generally don't do well with working with short-term memory, and along with vigilance tasks. For example, if I ask you to tell me precisely when it is 4:27 and 36 seconds p.m., people typically don't do well with that vigilance task. So, set a reminder on their watch or set an alarm on their computer, but it's generally something we don't do well with. And we also don't do well with finding items in very large lists. So, offloading some of that work from the short-term memory to visualization is a good idea. Resolution over immersion. Again, resolution is more important than immersion. Immersion is the feeling of actually being in the space. Resolution is the number of available pixels. Immersion environments are usually separated from the typical workspace. If you have a surface table that you're working on, or a 3D visualization or an augmented reality table, it's typically separated from your workspace where you're actually working on the computer. There are benefits to productivity if the visualization system is part of the desktop instead. So consider whether presence is worth the price of lower resolution. This one is from our graphical user interface design class, but it's listed again in Munster. And it originates from Schneiderman-Plaisant, who wrote the textbook on user interface design. And the idea is to overview first, then zoom in and filter, and then get the details on demand. So basically start with a broad awareness of the data set, and then zoom into the area that you want to explore. Use filters to break it down even further for the thing that you absolutely want to focus on. And then you can get the details for the individual items of most interest. So you keep going from the large to the small. Go from the overview down to the details. Responsiveness is another thing to consider when designing visualizations. Human reaction to latency usually falls into discrete categories rather than taking place on a continuum. Our perceptual processing takes about 0.1 seconds. Things that are immediate response are about 1 second, and brief tasks, we have about 10 seconds of tolerance for latency. So that's the time between the user's action and some type of feedback. Users should receive some feedback that a task is completed. And designed to generalize response time in a visualization system requires paying attention to the algorithm detail. How long are these algorithms taking? Are they giving us feedback quickly enough? And again, because some of these chug through memory quite a bit, they can actually cause a delay that's not tolerable for the end users. And even 0.3 seconds can cause problems, and I have a video to show you in the class for that. Other points in the chapter: get it right in black and white. Ensure that the most crucial aspects of the visual representation are legible, even if the image is transferred from full color to black and white. And the photo here, it's there for black and white shoes, but it underscores the point. The black and white text is legible, and the superfluous detail of probably the blue jeans there, doesn't really detract from the black and white portion of it. Interactivity costs, and it's good to let people explore, and it's good to allow them to have interactivity. But exploration requires human time and attention, and also requires a bit of programming. So determine whether the exploration aspects are worth the time or if they're necessary to accomplish the task. Again, thinking about the overall task, the why are we doing the visualization. Final thoughts, good visual form is important, but function is more important than beauty. And I always have to leave you with Jerry Springer's final thought, which is take care of yourself and each other.